Hi, I am Anand with the product marketing team at Infineon. Today, I want to introduce you to PMG1, a portfolio of high voltage microcontrollers with USB-C power delivery.
In the last few years, USB Type-C has been adopted into billions of devices in consumer electronics, and we continue to see exponential growth of USB Type-C into other embedded applications and IoT home devices. In this video series, we will discuss the different devices in the PMG1 MCU family and how to develop applications using a PMG1 kit with Modus Toolbox. Modus Toolbox is a firmware development environment for PMG1 devices, and along with the PMG1 SDK, it makes it simple to develop applications for PMG1 MCUs. Let's get started with an introduction to PMG1 MCUs. Infineon introduced PMG1 targeting consumer, industrial, and communication market segments that need a solution that provides and consumes power from a USB-C port and needs an MCU to implement product features. PMG1 integrates a programmable MCU with ARM Cortex M0 or M0 Plus with a market-proven USB-IF certified USB power delivery stack and high voltage circuits like high voltage LDOs, FET gate drivers, as well as over-voltage and over-current protection needed to enable a robust USB-C power delivery system. It provides a single chip solution for a lot of system applications, leading to simplified system design and reduced bill of materials. This slide provides an overview of the different devices in PMG1 family of microcontrollers. The slide lists PMG1 devices across feature set, GPIO count, and flash size. PMG1-S3 is the lower end of the product portfolio in features, GPIO count, and the flash size, while PMG1-S3 is the cream of the crop and comes with ARM Cortex M0 Plus processor, highest flash size, and rich feature set like USB full speed device, crypto accelerator for secure firmware load and boot, inbuilt capsons to integrate with capacitive touch buttons and sliders, 12-bit ADC, op-amps for motor control applications, and a high number of GPIOs for any system MCU functionality. PMG1-S3 supports only sync role, while PMG1-S1, S2, and S3 support both sync and source roles. PMG1-S3 to PMG1-S2 support USB power delivery 3.0 power up to 100 watts, that is 20 volts at 5 amps. While PMG1-S3 supports EZ-PDª 3.1 power range up to 140 watts, 28 volts at 5 amps. PMG1-S3 also comes in two flavors, the 48QFN supporting single port USB Type-C applications and a 97 BGA which supports dual port USB Type-C power delivery implementations. Some key feature difference between PMG1-S0 S1 and PMG1-S2 S3 are PMG1-S0 S1 come with PFET gate drivers, while PMG1-S2 S3 come with NFET gate drivers and integrated charge pump, so customers can use NFET for source and sync power path. PMG1 S1 and S2 also come with integrated USB full speed device. Please check our website for more details on the PMG1 devices and to compare the features across the devices. Once you have reviewed the PMG1 devices and decided on the device for your end application, you can order the appropriate PMG1 kit to get started with your application development on PMG1. You can see PMG1-S0 to S3 kits lined up here. You can order the kits for the appropriate PMG1 device using the links provided in the PMG1 webpage at infineon.com. Before you get started, you would need a USB-C AC to DC adapter and a USB-C to USB-C cable to connect to the kit. Let's now take a closer look at a PMG1 kit. All PMG1 kits have a similar board topology. I have here a PMG1-S2 kit. The kits have a USB-C portion of the board and a KitProg3 portion of the board. The USB-C portion of the board has the circuitry needed to validate PMG1 MCUs along with USB-C PD functions. The USB-C connector J9 is plugged into a USB-C power delivery source, and PMG1 MCU is used to sync power through this board. PMG1-S0 to S2 can sync up to 100 watts of power, that is 20 volts at 5 amps, while PMG1-S3 kit can sync up to 140 watts, that is 28 volts at 5 amps of power. The GPIOs, USB, and other serial interface pins are accessible through the headers on either side of the board. Customers can wire up these headers to different sensors to test their system. The Kit Prog 3 section of the board is used to interface the kit to a host PC where Modus Toolbox is being deployed to develop the firmware code. Users can hook up J1 USB-C port to the host system using a USB-C to USB-C cable. Here you can see a PMG1-S3 kit. It is slightly different from the other PMG1 kits. Since PMG1-S3 supports capsens, we have capacitive touch buttons and capacitive slider included with the kit, so users can deploy applications using them. All the kits ship with a USB-C power delivery sync firmware preloaded to the microcontroller. So you should be able to plug in a USB-C power delivery power adapter to J9 and sync high voltage power. As you can see, I have already plugged in a USB-C power adapter which provides a maximum of 20 volts at 3 amperes. If you measure the voltage across the load terminal, you should be able to see that the system syncs 20 volts. There. Now that you are familiar with PMG1 kit hardware, it is time to introduce you to Modus Toolbox, the firmware development environment for PMG1 microcontrollers. Thank you for watching.